Just some quick words about myself. As already introduced, my name is Francois Fernandes. I'm in the industry with PDF since 2005, so I basically started with PDFA, and this was actually my first contact with PDF as well. And I've been very keen and close to the PDF development since then, but I've recently changed a bit the perspective. I'm now on the evil side, on the other side, the actual users of PDF, which brings a whole different view on the topic that I would like to introduce you to today. So this means that my talk will not be with PDF at the center, but with PDF as part of the whole storyline of business processes and how to integrate PDF into modern software architectures. And when I'm talking about modern software architectures, I'm really talking about CQRS, yes. So you might very well ask, what the hell is CQRS, yes? That's a fair question, so let's have a look at it. Just getting a look at the acronym, we have multiple letters. One of them is the command and query responsibility segregation. I really think that this is a great title for an architectural pattern, but it's self-explanatory. I don't need to explain anything else. And yes, well, that boils down to event sourcing. Again, pretty self-explanatory. Now, the question is, what about PDF? Where can I have PDF in that whole story? And that as well is very easy. You create PDFs during the command phase, and you associate them with an event, and you're done. That's it. That's all I have to say. So if you have any questions, please go ahead. I see some fuzzled faces right now. You're not looking convinced. No? All right. In that case, let's start at the beginning. The beginning for me is, what do we face as typical challenges in modern software development projects? And one thing that is really driving a lot of development in companies is the rapid change of typical infrastructure that you're actually facing. Everyone is talking about the public cloud. Since years now, everyone is trying to go to the public cloud. And some companies are actually using private clouds, hybrid combinations of that, or even still on-premise solutions. And there's a lot of movement, really a lot of movement all the time. In addition, the classical server-based application is slowly fading away. We're moving to other concepts. Function as a service is one of the bigger words that is out there, but it brings us a number of new challenges. So the classical free-tier application is kind of the way out of the door. And it needs something that is more appropriate to what we're now facing as our challenges when it comes to a software infrastructure landscape. And not only the infrastructure is changing, but also the workload is really changing. It is changing on how much load is put on applications. And even internal applications are continuously getting more and more traffic due to ever-increasing workloads in multiple ways. And one of the worst things, we love our requirements when we do software development, but in all day long, we receive new ones that have been unexpected. How do we handle that? It is ever moving, and it is even moving faster from day to day. And one thing that is in particular for the company that I'm currently working for, a huge hassle is everything that is going into the direction of governance. So ensuring that what you do is traceable, reproducible in any single point in time, and you really are in control of what's happening. That is a rather big challenge. And new things like machine learning, for example, comes around the corner as well, asking for more data about what your processes do, what's happening, and all that. And this is my starting point. This is what I've I'm challenged with every day. And PDFs and documents in general are part of that story because they are part of all those business processes out there. And why do I think that CQRS, yes, is a perfect fit? For one, for that architectural changes in the infrastructure, our requirement changes, and for having documents as a key part of the whole story. But I will have to get a bit into the details of CQRS. The CQRS ES, that's hard to spell. Just a quick question in the round. Whoever has ever heard of CQRS ES or one of the both? 2 persons, that's great. So what I'm going to tell you now might not be any news to you. I will try to keep you entertained anyway. For the others, I will try to give a brief introduction, or even a more deep introduction into those concepts, starting with the latter, with event sourcing. What is event sourcing about? Well, in classical applications, your central point of truth is typically the SQL database. The current state of your business entities, of all that you know, is in that database. And things like having a history and knowing what happened in the past to those entities is always a challenge. Has any one of you ever tried to implement a versioning system within a database based on tables? I would guess so. It was a major pain. And these things led to what we now know as event sourcing. We're rethinking the kind of way on how we store data. We store data in the form of not the final thing, the final entity, excuse me, but the series that led to that final state. So we keep our history. To make it clear, let's look at an example. In our case, and I have JSON written examples here, the actual syntax is not as important. It is important that you keep events with some data, with the data that is important to you. My example is about having a business contact. A business contact typically contains a name, last name, date of birth, an address, and stuff like that. This is expressed as an event. In our case, the contact created event, or create contact event, however. And this is the initial thing, the initial event that starts our entity of that specific contact, which is called Maria Strong. Now, as it happens, as it often does, when time goes by, things change. For example, this woman just got married. And one thing that happened during that marriage is that she actually changed her name. And what's typically happening in such processes that these name changes, for example, for one, that is a specific typical interaction that you're doing with your system, and it is originated by some kind of message. And if it's written by a letter, which is a common thing, or via email, there's always some kind of document. And this is the missing link. So I'm having an event, something, an action happening, and I want to ensure that I always know that the thing that originated this action is actually that document stored either alongside the event or, for example, in a long-term archive. Going further down the line, that most certainly is not the only event. For some reason, again, sometime later, we see a serious move. So that lady just decided, well, I don't want to be in my previous country anymore. I'm just switching planets. And she lets us know, again, using a letter. And that's the another letter assigned to that specific event. I know that this is happening due to that document. Now, the key thing with event sourcing is that my knowledge is based on that whole history. I'm not keeping the current state somewhere. The current state is always built up from all those events that happened. That means I have a history. I always have a history because I'm using that history to build my current state. And the interesting thing is, not only can I answer the question, what is my current state, but also, how did it come to be? And things like asking the question for a specific contact, did the name ever change? In typical applications, if you're just reflecting the name change by replacing that field in that row in a SQL table, you know that it has been changed probably, or even you don't know that the change actually has happened if you don't have some kind of versioning or any kind of protocol taken with you. And in that case, you don't know. You can't answer that question. With what we have now with event sourcing, we actually have a chance to do that. And even better, we know which document was assigned to that and what caused that change. Or another question, did that person move? And the marketing team, for example, might at some point in time be interested in how often did that person actually move? Should we offer that person some kind of special insurance or something when they are actually moving that often? That's also a thing that you can answer now, because typically events are associated with a time step, so you know when it happened. So you can extract data that you never thought of upfront, but you might need them, but you will have that data. I'm very sorry. Now, this is one part of the story, but you can imagine that maintaining such an event source or such a chain of events can be quite challenging. So let's look at the other part of the story, which is CQRS. I already said that with what we're facing today, the architecture changes and the requirements on applications, that the classical three-tier architecture, so what we did with server-based stuff, is having a bit of a challenge. Why is that? Because typically we have one central point of truth. We have that point of truth that is used for read and write access. You always have that single point that is basically a blocking point when doing any kind of processing. And even more, that single point of access must serve all thinkable use cases. This typically leads to many different things stuffed into one table or one entity, or for stuff not to get associated at all, just to get associated by processes, manual processes or something. This is rather painful. And there we can have a change. With that command and key responsibility segregation pattern, we are effectively doing what the name just states. We are separating the writes, the commands, and the reads, which are the queries. So commands are something, it is an expression of an intent. For example, I want to create a contact, I'm creating a command that expresses the intent of creating that contact. Or I want to track the move of that person. So I'm creating the command that carries, in that case, that associated document stating that here in that document it is stated that this person moved for some reason. So an interesting thing again is the whole business logic is actually contained in that command, and it is encapsulated. Now, how can I query that if I'm not having the source? Because the command is writing its things in the write data model, which is completely separated from the actual read model. And the question to that is you have projections. If every time there's a change to your data, to your central point of truth, you derive something that is usable for you in another place. So this is the core idea of that whole segregation. And that even brings us to other very interesting things. I previously said that we have many use cases that all have to be served by a single data model. With that pattern, you don't have that anymore. You can have a specific read model for one specific use case that just serves that specific use case in the most optimal way. For example, keeping a history if you want to have a history of what's happening with your events. Or to see the current state, for example, in a contact viewing application where you don't care about the history or other things. And even better, you can separate that. And now it comes back to the infrastructure challenges. Instead of having both things in one data center location or even on-premise or in the cloud, you can split it up. If you're having some parts that are only internal, it should always be internal, for example, that document handling, that should be internal, then in that case, keep it internal. Keep it on your private systems. And where you have a customer portal where customers can look at their documents or their data, well, then derive a read model that is actually stored outside of the company data center in a public cloud. So you're basically offloading. But you're only offloading what you really need because you're very specific with your particular requirements. So how does that come together? How can we combine both things? Although CQRS and event sourcing actually don't need each other, they are not really linked with each other, they really work well together. And I will go into a bit more detail and a concrete example on how that actually works. And the thing is, with combining those, you can really streamline application development because you're concentrating on one thing at a time. Concentrate on the right logic and your core business logic on the one side and derive what you really need in that specific use case. So, but how do you do that? Well, you have three very key parts here in this story. You have the command handling logic, you have a write model, as already stated, and you have what we call the event store for event sourcing. So typically, the whole process go through the command handling logic, and the command handling logic will first check that they have the most up-to-date state based on the event sourcing of that write model. So I'm just collecting all those events, distilling it to the current state, and now I'm validating all what I have to validate against that state and determine which change would be initiated and what data should that change contain. For example, if I'm receiving a name change and I determine that only the last name changed, there's no need to specify that the first name is still the same, so I leave it out of the event. Or if that change is for some reason invalid, that's going to be in the command handling logic that validates and then decides what is the actual change that should be reflected as an event. And now it gets even better because we have the subject of how can I derive things? How can I derive my read model? Based on the nature of events, now, coming back to that, we store events in the event store. That's our truth. And events, as the name already states, that's something that is happening, but could be sent around. So a very common pattern that you see with that kind of architecture is that these events get actually published on an event bus. And the cool thing is, based on that, I can share that event with all parties that are actually interested in that. And I can derive multiple projections, many projections, as many as I need, and projections that are actually as relevant to my use case as they could be. So leave that data out that you don't care about, and just integrate what you really, really need in your use case. And that doesn't have to only be some kind of read models. I can, for example, do email notification, cause any kind of analytics to be performed based on those events, or generate documents based on what happened in the system as a fact, and I can always reference that. So That's the example or the foundation. And I would like to go into more detail how one process that I have been actually involved in developing really looks like. And when we decided to create documents and how we created documents. So the example that we will be going through now is actually an application for creating and editing and tracking invoices. It's a relatively easy billing system, but the wish was to integrate that as deeply as possible into the processes and ensure that we always are aware of the current state. Because that invoice might be edited by multiple persons, and it should even be possible to generate preview PDFs of a document, of that invoice, but always ensure that we know at which point in time that document has been generated, so it doesn't get lost in any way. And of course, in some point in time, we want a final version of that document. Again, that should be known when that happened, and we should know what is the current state of that invoice. And two final things. Invoices might be revoked for some reason because in the last minute you've seen that there is something wrong with that. And we want the consumers to actually have access to those invoices through a cloud portal that they are able to look into to see their own documents or their associated invoices. So given those interactions that I just described, I tried to summarize those into create invoice, adding position to that invoice. I didn't explicitly specify that, but that's typical for an invoice. I wanted to create a preview in some point in time that I could send out. And I would like to have the option to finalize the invoice, giving that invoice an actual invoice number, doing all the finalization stuff, including generating the final PDF document that is the invoice. And of course, revoking the invoice. As it so happens, these things that I've sketched here on the board, these are actually commands. So let's look a little bit deeper, because we already said that we have commands, we also have events. Events will be marked in blue. It will be upcoming. In addition, beside the events, we also have what we call the query. I'm rephrasing that for the moment because the term view resembles it a bit better. So we will have 3 different kinds of boxes now appearing. So we're going through the process. And if you're looking at those boxes from the left to the right, that's actually a storyline. I'm creating an invoice. I'm adding positions. I create a preview. I might even go back to adding additional positions afterwards, but sometime in that time I will do the finalization of the invoice and potentially revoke that invoice if something did go wrong. So what happens? These are the commands. Business logic is executed. As a result, for the create invoice, we have an invoice created event. And now comes the interesting part. I have the history of that. I know that there is the invoice existing as an entity. Now, I want to access that. I want to know that there is a invoice in a draft state. So I have to update the so-called invoices list in that case. It is my view. And we go through the whole story now, applying what we just did. Same for add positions. In that case, I have the positions added event, which store all my additional positions. Now the truth is the invoice created event, including the positions added. And as a result, the invoices list might be updated because I want to see the number of positions on that invoice in my table. But that's optional. I can do that. In our case, if they wanted to see the final price, was final amount, and how many positions are actually on that invoice. So that's changing. I have to update that. But beside that, I also have to update the internally kept invoice positions view. And it's really just a view to use to represent what's currently on that specific invoice. Now, I have the invoice in some kind of state that I'm pretty happy with. I would like to create the preview. And now that's the key thing. We have been thinking a lot where we can generate documents and how we can associate those documents with that whole process. And the best way was actually to ensure that these are in the command phase. So I'm finalizing I'm creating the preview. So I'm generating events stating I will do a preview. I'm collecting the current state of that invoice, generating the PDF, and only if that's succeeded with all validations, only then I will generate the PDF document, generate the event, and actually keep that document around with that event basically forever. It will remain. This, as a result, will also update the invoices list because we will see, well, there has been a draft, so you can click even on that list to see that current draft. And even if I'm going back to add additional positions and recreate a preview, that draft will be updated. I will have a new one, but the old one never goes away. It stays, so I always have full traceability of that specific document. We even investigated whether or not we would use incremental updates on the document, but it turned out, due to the nature of how those documents have been generated, incremental updates were not working for that case because reflow of a document and stuff like that. And so we really went with a new version of a document, which made it easier, but still we have the history. And there's another side effect of that. I might keep a document archive around because I have generated that preview PDF. I want to keep it somewhere specific. That's the other view, the very specific, the archiving view that I'm keeping updated. And I'm only updating it for that event because the other events, it is not important. Now comes the finalized invoice. Again, business logic, validation, stuff like that, and of course, acquiring an invoice number. That's always a challenge in by itself, but given that I have successfully acquired the invoice number and I'm generating the PDF document, that is the final invoice, just when that is done, it is actually being published as an event, again, updating the invoices view, and the document is available. But no, not only that, I previously stated that we, for one, want to archive that document. Well, we do that first. And the other thing is, we want our customers to see those invoices. So we have a totally different view, the external invoices view in that case. That is really external because it was running in public cloud. So only data that is really required did leave the actual company data center just to ensure that those customers are able to retrieve their invoices. Now, we all know that sometimes things really go wrong, and in those cases, you might revoke an invoice. And again, that was actually an incremental update that we have been doing, using the final version of the invoice, adding a overlay stating stale or outdated and invalid. And again, same thing. It got an event, it was stored in var archive. The external list was updated in the sense that it is actually withdrawn from that portal, so that if that document doesn't exist anymore, it is not accessible for the user any longer. And of course, the invoices list got updated as well. So this is the whole technical process. But given that, we can quickly see which kind of interactions are actually required for the system. And so let's extend that view a bit into UI components. And we have two kinds of consumers. We have the internal consumers, so the service agent, and external consumers, the ones that are actually using or retrieving that invoice. So we really easily can determine, well, the agent, internal agent needs something, some UI to start invoice editing, starting the invoice editor. They might see the newly generated invoice in the lists, in a listing view in their application that they can select and go to do the editing. Finally, we have an invoice editor that is actually causing the adding of positions. And finally, once positions are added, again, that's going to be updating the invoice editor. Because, and that's the interesting thing, I'm generating those commands, executing them, and my actual view is served by some kind of view that is derived from those events. So I'm always keeping the correct state in both client and server. And we can go further down the line, even to the point where it comes to external situations. For example, the external invoice list that the customer is actually using, and they also would have an invoice viewer, which is also served by the same view, basically, to use and see their invoices. And the final thing, okay, we have an invoice viewer because the document is actually finalized, or the invoice is finalized, but we need to revoke that. That should be part of the viewing component. The thing that we went just through here is actually called event modeling. It is a way of describing what is happening in your system, what your system should be doing, and what the interactions actually are. So the cool thing here is that I, for one, see what's happening. For example, where are documents generated and where are they associated? And for the other thing, you know which kind of UI elements do you actually need to do that workflow. It is an easy way to fully express your whole process and how it should be made visible to the user and which kinds of events are stored, and keep your history.